My name is Roger Buse and I'm the Managing Director of Hegner UK. Thank you for sending for information on the Hegner HDB 200XL lathe. In this video we will show you the many features on this lathe and followed up with a demonstration by Nigel Voisey and David Roberts on the lathe.
When you first begin turning, turn small workpieces to minimise the forces that you'll experience. And the best tip that I can give you is to turn 100 of something rather than ones and twos of this and that. When you turn successive pieces, you become familiar with the reactions and the forces at work, and you learn to overcome the difficulties that you'll inevitably experience, and you're on a safe road. Here I'm going to turn an egg cup, working with the 50mm screw chuck. That's a piece of yew. Position the tool rest and always check that you have clearance for the work to turn before switching the lathe on. I'm going to use a roughing gouge. It's quite a simple tool to use. It's important that the heel of the bevel is allowed to contact the work before the cutting edge. Try it without the lathe running. Do what I'm doing here, which is to rotate the work by hand to get an idea of the angle at which the tool has to be held in order to bring the cutting edge to bear in a controlled way. If I were to raise the handle, it would take off a much heavier shaving than would be safe. Here, the angle of the tool controls the depth of cut. Checking clearance, making sure everything's clamped up solidly, adjusting the tool rest height. About centre height is comfortable. When switching the lathe on, switch on with the lathe set to run at a low speed. You can't have any nasty surprises. In small work it's not so important, but as you turn bigger and bigger pieces, it's good to get into good working habits. Adjust the speed to something that's comfortable. In this case I've turned the speed setting to about 1500 RPM. Work from the centre towards the end of the work rather than starting at the end. This design enables me to retain some of the natural nature of the workpiece. Here I'm scraping a small recess in the end that is to be hollowed out so that the gouge bevel has something to rest against. It's much easier to control. Hollowing out, keeping the bevel rubbing. If gouge work has been reasonable, then the final scraping just evens out the slight ridging that will be left by the traversing gouge. Notice that the scraper is bringing off shavings rather than dust. I'm just making a step, a V-cut in fact, so that I have something for the bevel of the gouge that will finish this shaping to rest against. Provided the bevel has got something to bear against, the gouge can't do anything unexpected. Now here I'm severing the fibres before removing the waste. This prevents the damage caused by a flat tool such as this beading and parting tool from extending along the surface of the work. Just using a roughing gouge to quickly remove the bulk of the waste material, just some preliminary shaping cuts. Now here these are finishing cuts with the spindle gouge. Again I'm applying the bevel of the tool to the work first, then feathering the cutting edge in. You see the polish that's left by the tool when it's presented in this way. Notice how the gouge is rolling nearly onto its face in order to keep the shaving coming off the leading edge and the bevel of the tool rubbing. Again, if you find difficulty with this cut, try it with the lathe switched off, just to see the position that you have to get the tool into to keep these rules working. Same principle again, feathering the cutting edge in, keeping the shaving coming off the leading edge of the tool, working downhill, that is from the larger diameter to the smaller diameter. I always enjoy this type of turning because it's quite feasible, desirable in fact, to get a finish straight from the tool. I'm just using a piece of scrap wood here to burn a decorative ring on the end of the head cup. Some final shaping cuts. Use a particularly nice wood for this sort of project, as it's such a variety of colours and figures in the grain. This is a nice moment, switching off the lathe for the first time to see the actual colours and pattern of the grain. Now, very light sanding will remove any tool ridging, but sanding shouldn't be regarded as a substitute for good tool work. I'm using about a 320 grit paper. If you start with a coarser paper, you'll put scratches into the work. Of course, sometimes that's inevitable, but then you have to sand with progressively lighter grits. Having sanded, I'm just burnishing with a handful of shavings. Be careful with the unturned part of the work. This is a chestnut finishing product. This is a cellulose sealer. Just wiping it onto the surface of the egg cup, it provides a good base for the polish and prevents the changes in humidity in the atmosphere from affecting the final finish coat. Of course, this wouldn't be a waterproof finish as such, so if this egg cup is to be used, then it should be wiped clean rather than put in with a washing up. Now I'm going to apply a lacquer finish, which is a spray finish, and it's extremely effective and very, very quick. I'm just giving a very light rub with quadruple O wire wool. Then I'll mask the lathe with a piece of board. Turn the speed down. Simply so that overspray doesn't cover the lathe. You see I've used extremely light application, and that's quite sufficient to give a very, very high finish. That is the finish as it comes from the can. Now, in this particular case, I'm going to make an egg to fit into the end of the egg cup. I previously drilled out the blank with a 1-inch diameter hole. This is going to be a pin on which the egg blank will be mounted. You could use the proprietary pin chuck, but I find that very often a wooden pin is just as effective, more effective sometimes. I'm just going to remove the waste and reduce the diameter of the pin to the diameter of the hole I drilled in the blank. I'll use calipers for that purpose. It's probably best to use a parting tool in conjunction with the calipers, probably more accurate. But this is quick. I'm going to cut this with a slight taper so that the egg cup, or the egg blank, will sit firmly on its mounting. I've just removed some of the waste there so that the tool has plenty of room to work when I put the new blank on. It's the pre-drilled hole. This is a piece of sycamore, just jammed on. Remove the corners with the roughing gouge. Again, applying the bevel first, just slowly lifting the handle to feather the cutting edge in, working back and forth. Just reduced it to approximately what I think is the diameter of a standard egg. Removing the waste. Now begin shaping with a skew chisel. This is a tool that a lot of people find difficult to use, but once you've mastered the feel of the tool, feel of the bevel floating over the work, then it becomes much easier to use, much more pleasant, and it does produce a finish that no other tool can. When making cuts of this nature, try to complete the cut. Even if you inadvertently run out of cut, get used to the idea of heading for the final point of the cut and continuing until you get there, rather than worrying at little ridges and so on. Another useful tip is to keep your elbows into your sides while making these cuts. The tool seems to be a lot easier to control with your elbows clamped into your sides. Showing the cut from a different angle. Having completed the turning, you could then drill a single hole, if this is to be a salt cellar, or 5 holes I find useful if it's to contain pepper. I'm sealing it, cellulose sealer. In this instance I've applied a wax finish. Turned a wooden plug. If you make 50 or 100 of these, you'll be on the road to learning how to use all the tools. Roger Buse has asked me to explain some of the features of the HDB 200 XL, which really set it apart from other wood turning lathes in this price and performance category. When we look at advertising for various machines, it's sometimes quite difficult to sort out what the machine really is capable of. So I'm going to explain something of the technical background to this and the features which really do enable it to do what we claim for it. In relation to capacities, the center capacity, that is the term we use to describe the distance between the drive center and the tail center, is such that you can turn a handrail spindle, which is a standard length of 39 inches. You may not have that in mind, but if ever you come to sell a lathe, that's a pretty normal requirement for most people, to be able to turn a handrail in one length, a handrail spindle in one length. The tailstock is adjustable so that it can be slid to whatever position you require for different lengths of work. The maximum capacity is 39 inches with the revolving center fitted, or 40 inches with a dead tail center fitted, which doesn't project quite so far. The swing of the lathe refers to the maximum diameter. The swing over the bed, in this case, is 16 inches, which is really a very big swing indeed. It means that theoretically you could mount a piece of work 40 inches in length by 16 inches in diameter between centres. Although you may not want to do that, there may well come a time when you do want to use this facility so that you can find the best mounting position for a turning blank that you're going to eventually mount on a faceplate or in a chuck, so that you mount the work initially between centres, either to find the centre of gravity or to retain or include some feature in the piece of wood that you'd like to. And that, again, is a very large capacity for this type of price of lathe. With the headstock swiveled, and in this case, the swivel clamp is under the headstock here. This is on a sprung spline arrangement. As you press it down, so it disengages, so you can position the handle wherever you want it to be, so that it doesn't obstruct your turning or the work. Unclamping it, clamping it, releases the clamping mechanism so that the headstock can be swiveled to whatever position you require it, at an intermediate angle or 90 degrees, so that the nose now clears the bed of the lathe, and large diameters up to, in fact, about 30 inches can be turned without any problem. With the optional bowl turning attachment fitted, that's this assembly here, that gives you the facility of being able to position the tool rest, cross-slide assembly here, so that you could work around any bowl form or turning blank up to the full capacity of the lathe. Another nice feature of this is that the headstock can actually be swiveled through 360 degrees, and although the advantages of that may not be immediately obvious, what you can do in this instance is, with this out of the way, you can mount a big disc behind the lathe. Now that will be rotating in this direction, so the tool rest can then be repositioned to work on the rim of, say, a large spinning wheel or a tabletop that you want to put a moulding on, and that's another useful feature of this design. Regarding standard equipment, we want to know what comes with the lathe and what you get when you open the box. Well, essentially, the lathe is delivered complete, more or less as it is here. The motor is detached. All that has to be done is for it to be fixed to the machine. There are 4 cap screws supplied. The lathe from the bench top up to here, as you see it, is included in the basic specification. That gives you the facility to turn spindles up to 40 inches, diameters up to 16 inches, swiveling headstocks included. The control box is included. It's full electronic variable speed with various features which I'll talk about in a moment, but it doesn't include the support arm. That's an option. The control box can be mounted on a timber post coming straight up from the back of the lathe, so it's positioned more or less where my hand is or wherever you find it's convenient. Or of course you could mount it anywhere you choose, but generally speaking that sort of location or here is convenient. The accessories include the tool rest, a revolving tail centre. This centre in fact has a removable sleeve so that it doubles as a ring centre and as a 60-degree centre. It's a twin-bearing, heavy-duty centre, so it really will carry the sort of weight of work that you can put on this machine. The cam operation for the tailstock I'll talk about again in a moment. All that is included. The cross-slide assembly, again, has a cam lock, which is part of the basic specification. The tool rest clamp can be positioned in any of 3 different locations so that it never interferes with the sweep of the tool. The headstock rotates, as we've discussed. The variable speed gives a range of speeds from a bottom speed of 90 RPM up to a maximum of 3,800 RPM. That's achieved through 2 pulley ratios, which I'll show you in a moment. The other thing that's included is this 4-prong drive centre and a thread protector. All the fittings are number 2 Morse taper, so they're heavy duty. The spindle thread is the standard European thread for heavy lathes, which is a 33 millimeter. So looking at the controls that are featured in a little more detail, speed range is adjusted by turning this rotary dial. The numbers on here correspond to the numbers on the scale here. So if we select number 6, then on the low pulley ratio we get a speed of 495. If we have selected the high pulley ratio, then we get a speed of 2295, and so on. So it's quite simple to adjust. When we look inside the headstock, we'll see the way in which the drive ratios are switched from high to low. The lathe also features a forward and reverse switch. It's quite useful for polishing and sanding difficult areas. It's not used for turning generally. An on-off switch, which is the main control for on and off, but we also have an emergency stop which incorporates a no-volt release circuit. It means that if the power is disconnected for any reason, then the lathe cannot restart accidentally. You have to raise the flap and deliberately restart it. It also has a thermal overload cutout protection. Changing from one speed ratio to another is simply a matter of releasing the hinged lid, releasing the motor clamp, lifting it forward, and moving the belt from one pulley ratio to another. Reclamp, and now we're running on the low ratio. While we're looking at the transmission, you can see the numbers here on this indexing ring. These relate to the positions in which the shaft can be locked, any one of 24 different positions. This little detent plunger locates in holes adjacent to each number so that the work can be divided into segments, up to 24 segments or subdivisions of 24. And that's useful if you're reading or fluting a column, or if you're putting decorative plugs around the edge of a bowl, and so on. Radial drilling for mug trees. It's quite a useful feature to have. Regarding the bed of the lathe, there's a lot of discussion about tube versus solid, and it's generally considered that solid is a better bed than tube. Now, in fact, within certain constraints, a tube gives a much stiffer surface for the various components of the lathe. A solid bar will bend under a given load, whereas a tube of specified wall thickness will not. And in this case, for example, the box section that the bed is constructed from has 4 millimeter wall thickness and will support about 20 times the load of an equivalent solid bar before it actually deflects under a given load. So a tube is, provided it's a strong tube, is much better than a solid in this particular application. Also, the bed is responsible for controlling the relationship between the tailstock and the headstock. So it's important that it's accurately constructed. Now, in this instance, the whole assembly is welded and then ground to a finished dimension on the slide surfaces on top here, and then on the inner faces. Now, the point of that is that the tailstock slides, but in most instances it's necessary, certainly with a flatbed, that the tailstock has some key to locate it in the bed, and there must be a clearance, a working clearance there. And now in most lathes of this description, that's just a clearance which allows the tailstock to move from side to side as it's located in different positions. Now, on the Hegner lathe, in fact, under the tailstock body are 2 sprung plungers which take up that working clearance, so that when the tailstock is released at any position, that working clearance is always taken up against this datum face. It means that wherever you position the tailstock, the alignment of the tail center and the head centre are guaranteed to be absolutely precise. Once you set the tailstock to the position you require, it's simply clamped by means of this lever. This operates a cam, a machined cam, under the lathe, under the tailstock. It works in line with the bed, parallel to the line of the bed, so there's no twisting moment as there is with a clamp which operates across the plane of the bed. This means that the alignment is protected. When it comes to aligning the tail centre with the headstock centre, in the case of the HDB lathe, this spindle is ground to a close tolerance with the tailstock body. This means that as it's clamped by means of this clamp here, there's no loss of accuracy through excessive tolerance being taken up by the clamping action, kicking the spindle one way or the other, so that there's absolutely no deviation from the required setting at all. Tailstock and headstock alignment aren't the critical factors that one might imagine for turning between centres. In fact, some lathes have an offsettable tailstock for turning tapers with a mechanical carriage mechanism. But in case of lathes for a variety of work, such as bowls and faceplate work, chuck work, the alignment of the headstock and tailstock can become critical. If there is misalignment, then when you bring the tailstock up, say to drill a workpiece, a hollow vessel, if the tailstock is out of line, then that will set up real stresses. Also, if the work is mounted on a chuck or a faceplate and the tailstock is out of line and brought into use, then again that will, in extreme instances, actually pull the work off the chuck. So the question is, how do we check that the tailstock and headstock centres are actually in line? Well, the KISS test is a simple test, but that doesn't tell you, in fact, if the bores of the headstock spindle and tailstock spindle are in line, because it's possible to adjust the centres so that they kiss, but the real test is when you withdraw the tailstock spindle to its fully retracted position from its fully advanced position, then bring the tailstock up and make sure that the centres are still kissing, as here. This shows that the bore is actually machined parallel to the bed and to the turning axis. Most lathes in this category are fitted with standard radial ball bearings. They're single row of balls running in a track which is sealed. Now, this type of bearing is good for absorbing radial loads, but isn't ideally suited for coping with the axial loads. That's loads along the length of the spindle. Now, in fact, the HDB and all models with the XL suffix now have a twin-row angular contact ball bearing. This is an adjustable bearing, although it's in fact sealed, so it's maintenance-free. But what it means is that there is absolutely no hint of any radial or axial play detectable in the spindle. In practical terms, this means that you can hollow out on the ends of long pieces without the usual chatter and screech that you get from the tool, which is attributable to the bearing actually moving between its the tolerances that are permitted by the clearance, the working clearance in the bearing. In this case, that doesn't happen. So you get absolutely superb performance in terms of hollowing out or working on a piece which is unsupported by the tailstock. So that really covers the standard equipment and the basic specification of the Hegner HDB 200XL lathe. We'll deal with the accessories in a moment, but the principal options that you have to consider when you're thinking about ordering the machine are motor power and the main accessories that you might require, which are really a part of the lathe in a sense. The standard motor is a 3/4 horsepower, which really in terms of the general turning is adequate, but because the lathe really offers such huge capacities, I personally would recommend the 1 horsepower option with the upgraded electronics to cope with the additional motor power. That adds a little to the price, as you'll see from the price list. Another option that is best considered at this point is the bolt turning attachment. If you're not actually going to buy it, then at least make provision for its addition at some later point. That will affect the design of your workbench. The bolt turning attachment simply clamps on to the bench underneath the lathe and offers a facility to relocate the tool rest. Relocating the tool rest in cross-slide assembly is simply a matter of undoing this retaining nut, and relocating the assembly here. To adjust the clamping position of the handle, put the handle in the required clamping position, say here, and then simply tighten this nut until it's now the handle will clamp in either direction at that position. In this position, the tool rest can be slid to whatever position is required for the work that is in hand. You can purchase an additional cross-slide assembly so that this can be left permanently mounted to the bolt turning attachment. As you can see, it doesn't take very long, in fact, to relocate the existing standard cross-slide assembly from the bed to the bolt turning attachment. The bench is quite an important part of the lathe assembly. It needs to be rigid and fairly heavy. You can build a bench however you like, of course. These two legs allow you to build the bench very simply, and it's a substantial construction. All that you need to do is to cut two rails for the top of the bench, which one here, one here. They're cut from 6x2 timber to the appropriate length so that the legs supporting either end of the lathe. Two additional rails for a shelf here. They're made from 4x2 timber. A shelf can be made from MDF or ply. The bench top itself, as here, is made from 19mm MDF. On this particular construction, we've panelled the bottom of the bench so that the top forms a trough which can be filled with oil-damped sand. That adds to the dead weight of the lathe and improves turning performance on any machine. The cost of these is shown in the price list. The height of the lathe centres is quite important from the point of view of comfort, working comfort when you're turning. Rule of thumb is that the centre should be at about elbow height. As you can see, this is probably a little bit low for me. The height from the centre to the bench top is about 420 millimetres. If you're building your own bench, the bench could then be brought to a level to give you a centre height according to your own requirements. An alternative is to mount the bench legs on these adjustable feet, which have an anti-vibration function as well. These enable you to raise or lower the lathe centres to whatever is comfortable for you. Accessories for the machine fall into various categories. The face plates that are offered for the HDB are two diameters, 100 millimeters and 150 millimeters. Either will give you enormous holding power for very, very large work pieces. We supply a nylon washer for all the accessories. They simply screw onto the spindle nose, having been previously screwed onto the workpiece that you're turning. The next category of fixing device, mounting device that we have are the screw chucks. There are three sizes for the HDB lathe. All of them have a recessed centre so that the leverage forces exerted on the work while you're turning are transmitted to the outer edge of the chuck. That gives a much superior holding power to the flat-faced chucks. Also, these have a helical screw which gives tremendous holding power in a pre-drilled hole in the work. The two smaller chucks, the 40mm and the 55mm, both come with screws. The screws are interchangeable with a pin. The pin chuck is inserted in place of the screw and secured from behind. That is in turn inserted into a bore in the work, in this case a 1-inch diameter bore, with a pin which is free to roll in the eccentric part of the chuck body. As that twists against the turning force, so it locks the work in place. It's very useful for things like pepper mills. The largest of the screw chucks is the 70mm diameter. This in fact is a faceplate rather than a dedicated screw chuck, but this has the advantage that the screw holes are drilled at an angle of 15 degrees. So when the screws are inserted, they effectively dovetail into the base of the work. Alternatively, of course, it can be used as a screw chuck with the screw fitted, or as a pin chuck with the pin fitted. This is a conventional drill chuck, which will take tools with shank up to 13mm diameter. It's fitted with a number 2 Morse taper arbor, so that it can be used either in the headstock or in the tailstock. In the headstock, for example, it could be fitted with a drum sander or a flap wheel. In the tailstock, it can be fitted with a Forstner bit for drilling out the centre of a hollow form down to a predetermined depth prior to the shaping work that will go on. The 4-jaw scroll chuck has become a very useful accessory for wood turning. It has the advantage that the jaws can be wound in or out with a key, and jaws of different profile with dovetails and gripping features can be fitted to the individual movable jaws. Simply screws onto the chuck nose, and provides an enormous range of work mounting options. The standard 10-inch tool rest gives a good range of possibilities for turning work on the faceplate or spindle work. For close access to the turning centres, the cross slide is angled so that the rest can be positioned like that. For very close work, such as lace bobbins, then the standard rest can be replaced with a cranked rest, which enables the tool rest to be set actually on the turning axis. For general spindle work, there's the option of a long tool rest, which simply means that you can take longer sweeps before having to reposition the rest down the length of a long spindle. The deep hollowing rest is useful for getting a tool rest into situations, locations which would otherwise be very difficult. It consists of 3 basic parts in its standard form: the tool post itself, followed by the adjustable sliding element of the tool rest support, and a hand rest bar which can be located outside the work, either for resting your arm or, in this position, the tool. With this bar slid into position inside the work, the hole here can be used either for a stop pin or can be used as a fulcrum pin to stop the tool running off the end of the bar out of sight, or with a fork so that can be used withdrawn to allow the tool to be inserted deep inside the work. The tool rest can also be used, positioned as here, so that this bar is providing support for the tool across the mouth of the work. You'll see Dave Roberts a little later demonstrating this technique. The components that come with the standard setup are the tool post, the tool rest bar and the handrest bar. Both the fulcrum pin and the fork are optional accessories to the assembly. Another accessory that's maybe useful, particularly for doing long slender work such as spindles, is this steady. It has an advantage over a 3-point revolving bearing steady in that these jaws are the steadying element in the assembly, and they have a much cleaner steadying effect than bearings. Bearings have internal clearance which allows them to chatter, whereas traditionally steadies were made on this principle, a simple V-block which was brought up behind the work. This clamps over the rest wherever you need it very quickly, and then the jaws are adjusted. You have universal adjustment so that they're brought to bear on the work. Turning is done, the steady and tool rest can be moved along as and where needed. The standard jaw will steady work from 20 millimeters up to 50 millimeters in diameter. For smaller diameters, there's an optional jaw plate which will steady work from 6 millimeters to 20 millimeters in diameter. One of the interesting and useful projects that can be undertaken on the lathe, of course, is making standard lamps. And to drill the long flex hole that's necessary right through the centre of a long spindle, we have the long hole boring kit. It's probably easier to show you how these various elements work together to enable you to drill a long hole by an actual demonstration, and that's what we'll do in the next section of this video. Well, I hope we've been able to show you why the HDB lathe is in fact truly unique in many areas of its design and construction. When you begin turning, there are a lot of unknowns, and it's nice to know, or perhaps to see, what the various tools are used for, how they're presented to the work, so that you know that you're embarking on a safe road in your approach to wood turning. We'll take a trip to Dave Roberts' workshop where he uses an HDB lathe, and we'll demonstrate some of the basic tools and how they can be used safely and productively. A 1/4 inch roughing gouge saves time when reducing the stock from a square. At this stage I clean off the end and make it slightly concave so that the two halves of the lamp will seat together nicely. I carry out all the rough turning work first and then complete the long hole boring operations before actually turning the contours and the detail on the lamp stem. In that way the centres, the tailstock centre and the drive centre, will centre on a pre-drilled hole so that all the subsequent turning work is guaranteed to be concentric with that central hole. And that way the two halves of the lamp, or three sections in this case, will join together perfectly. I'm now going to replace the conventional centre with this hollow ring centre. It has a ring nose with a removable centre point that allows the long hole boring auger to be entered through the tailstock, through the centre and into the work. Initially I'll leave the centre point in so that it can centre on the indentation made by the conventional centre. Now I'll use some wax on the ring centre just to lubricate it. Remount the work between centres. And bring up the tail centre. Now we'll wind the tail centre into the end of the work. With the lathe now running, advance the tail centre so that the ring cuts a shallow groove in the end of the work. Switch off. The ring centre has now cut an indentation in the end of the work, and the centre point needs to be removed. The ring is now clear so that the long hole boring auger can be fed through the tailstock into the work, which will now be supported by the ring. Bore in about half an inch or so at a time so that you can withdraw the auger and clear the waste. Careful not to damage the tip of the auger on the back of the centre. To feed it in gently until it meets the wood. We'll bore halfway, approximately, then reverse the work and complete the boring from the opposite end. Having completed the first half of the hole boring operation, we reverse the work on the lathe, and the end with the hole in it now has to centre on the drive end. So we replace the conventional 4-prong centre with a counterbore drive centre. The peg nose centres in the pre-drilled or bored hole, like that. I've now replaced the conventional drive centre with the 4-prong counterbore drive centre. At the tailstock end of the lathe, I've left the hollow centre in place, but I've replaced the centre point so that the centre point can now centre the ring. By switching the lathe on and advancing the tailstock, the ring will cut its seat in the end of the work. Having completed the long hole boring, we're now going to drill a counterbore, which is a larger diameter hole concentric with the central flex hole. This will enable a tenon turned on a mating piece to enter the counterbore hole, so we'll have a perfect joint. So we simply switch the lathe on, slow speed, and stop the work turning by hand. Then advance the tailstock. It's important when counterboring to stop the lathe quite frequently to clear the waste from the gullets of the cutting wings. Now for the actual turning of the piece, the counterbore centre can be left in place because this naturally centres on the hole that you've just bored. At the tailstock end, the conical nose of the tail centre will centre on the hole at the other end. Now we're going to cut a tenon on the one end of the piece opposite the end with the counterbore in it. So we'll caliper the diameter of the centre here and transfer that dimension to the tenon that we're now going to cut. Long spindles often have to be joined, of course, and in this case the join is made at a point where two features come together in the form of a V. It could be two beads, or in fact anything which will disguise the joint. When putting the joint together and gluing it up, make sure that the timber grain matches up, so the joint will be invisible. Certainly in the early stages of a wood turning career, before you know what is actually needed and what is superfluous, it's easy to spend a lot of money unnecessarily. This basic set of tools will enable you to turn virtually anything between centres and a lot of small work on screw chucks and that sort of thing. For bowl work, an additional long and strong tool is recommended. Once you've mastered these tools, then you can add to them as you actually find a need. In this set we have a 3/4 inch roughing gouge, a 1/4 inch spindle gouge, 1/2 inch spindle gouge, 3/8 square beading and parting tool, 1 1/4 inch skew chisel, conventional parting tool, 3/4 inch skew chisel, and a round nose scraper. We'll demonstrate how these tools are used, what their various functions are, in this demonstration. This is a roughing gouge. They come in various sizes. It's used for taking the corners off square stock, but it's also very useful for preparing long flowing curves before finishing with a skew chisel. It's very simple to use, and I'll demonstrate it. Always make sure that the tool is on the rest before it touches the wood. Put the bevel of the tool on the wood first, so that it's not cutting. Raise the handle slightly, and you take off a measured thickness of wood. Although the roughing gouge is primarily used for taking the corners off work and rough shaping, it can also be used to produce quite a good finish by using either the trailing or the leading edge at an angle. So normally the tool is used square to the work for roughing down, but if you angle the tool so that the flute is pointing back from the direction you're travelling, then the trailing edge of the tool can be used to produce a fine shaving, rather like a skew chisel. That can be done in either direction. I'll just show you that. This is a skew chisel. They come in various widths. A lot of people find them perhaps difficult to use. It isn't that they don't comply with the rules that govern the successful presentation of the tool to the work. It's that they tend to be less forgiving because of the broad cutting edge. We only use a part of the cutting edge for virtually all cuts. It's applied to the work, bevel first, as always. I'll show you how this is done. It's best to practice on small diameters rather than larger diameters such as this. It reduces the forces that are at work. Always place the tool on the bevel, on the tool rest first, and then the bevel contacts the work before the cutting edge, so that ideally you can turn the work and it won't remove a shaving. Angle the tool, change the angle of the tool until you just begin to take a shaving off the work. If you think about it as carving, if you were carving with this tool, you'd place the bevel on the work first, raise the handle until you find the point of cut, and then you produce a shaving of controlled thickness. So we'll do this in practice. Always start from the centre and work off the ends. If you attempt to plane coming in this way, there's a great danger, in fact almost a certainty, that the cutting edge will be buried in the work and you'll have a monumental dig-in. So plane off the ends of the work. The skew chisel is also very useful for rounding over and finishing long flowing curves. Start near the end, taking a small cut, rolling the tool slightly. The next cut, come back a little bit. Another very useful and important function of the skew chisel is for facing off damaged shoulders such as this. This has been cut with a parting tool, and as you can see it leaves a very, very rough finish. That damage will extend back into the depth of the timber. It's important to remember that it's only the extreme tip or point of the skew which is doing the cutting, and the direction of that cut is controlled by the edge of the bevel back from the tip. So the tool is applied to the work in this way, with the length of the cutting edge angled slightly away from the face. If the cutting edge actually touches that face, it'll certainly dig in. The closer the cutting edge can be angled to the face, the cleaner the cut will be, but also the more precarious. Another function of the skew chisel is in cutting square pommels. Here the tool is held initially at 90 degrees to the rest, so that just the tip scores and breaks the corners of the work. Then successive cuts are made from either side, working to that line, again making sure that only the point makes contact with the work. Spindle gouge is used for coving and rounding over. In fact, it's the only tool that can be used to cut a clean-bottomed concave shape on the work. As with all the tools, bevel first. When you're starting with this tool, it's helpful to remember that the tool wants to screw back along the work as you apply the cutting edge, and it needs some control, some force to stop it doing that. One way is to angle the tool so that the point is pointing at the turning axis and allow the tool to cut a step for itself before actually proceeding with the cut. Once the tool has something for its bevel to rest against, then the handle can be lowered and the cut picked up. An easier way of coving is to use a rebate with walls by the side. Checks the tendency of the tool to run off in either direction. So you simply allow the tool to lever against the wall, bring the bevel onto the work, feather the cutting edge in, The gouge is also very useful for rounding over and rolling large beads. It's important to start the bead, even though it might be a large bead that you intend to produce, or a large round, to start near the edge and then take progressively The 3/8 square beading and parting tool is a very useful little tool to have. It can be used in a confined space for planing cuts, if this was a parallel cylinder. It's also useful for just cutting shoulders on little features such as this. The beading and parting tool is also useful for producing small details such as small beads, using just the corners. Roll the tool as a skew chisel, using just the point. The wasted parting tool is used for cutting critical dimensions such as dowels, but it does leave a very poor finish. Generally used in conjunction with calipers, which are set to the diameter of the dowel that you require. Hold the parting tool in one hand. Finally, small scrapers are used generally for producing detail in end grain rather than across the grain. If they are used across the grain, they produce a very poor finish indeed. For a closer look at the use of bowl turning tools, we've asked Dave Roberts to demonstrate the tools and the techniques that he uses. Dave is a regular contributor to Good Woodworking magazine, and in the last 2 years he's won virtually every major prize at the national and international wood turning shows. Dave.
Nigel.
Looking around your workshop, I see you've got a vast collection of tools in different racks, but you've selected 3 which you use to produce most of your work, this type of tool. Can you explain why?
Yes, I will. This is the 1/2 inch deep fluted gouge, and this is the 3/8. Both of these are ground at an angle of about 35 degrees.
I see you've got a bigger tool here with your own handle. This is also an Ashley Isles gouge.
Yes, it is. But the long handle enables me to have more control over the work. Again, deep fluted, the wings are cut right back, and this will enable me to get the shear cut action. Also, it's ground at 60 degrees, which when worked along the bottom will give that nice cut.
Right, so you could grind this gouge in the same way that
Yes,
you grind
you
a bigger
can.
one and
Yes,
get
you
the same similar result.
Absolutely, yes.
Yeah. Okay, well we'll ask you to demonstrate them.
Right. I have now mounted the bowl blank onto the screw chuck. It's helpful to put the Tommy bar in to lock the spindle, just to make sure that it's really tight on there for safety reasons. At this stage now, bring the tool rest across, make sure it is plenty of clearance, and adjust the tool rest itself. We'll turn on and adjust the speed. With these cuts, I'm going to put the heel of the gouge onto the timber and then raise my right hand to bring the cutting edge into play. Right, I've just now brought the bowl into balance. It is important to keep the bevel of the gouge rubbing on the timber. With this, you'll be able to control the depth of cut. When I'm facing the gouge this way, I will basically use from the centre to near the edge of the gouge. And with the bevel rubbing, you'll get clean, even shavings. I am now shaping up the outside of the bowl. It's important to keep the bevel rubbing and make the shavings come off the leading edge. Here I am preparing the recess for the dovetail jaws. Alternatively, I could use a faceplate with a scrap piece of wood with a turned recess in it, the same diameter as the foot of the bowl. The foot is then jammed into the recess and is held by friction. This used to be a very common way of working. A modern scroll chuck with its expanding and contracting jaw features simply gives a wider range of mounting options and saves some time. This chuck has interchangeable jaw sets of different diameters and shapes so that it can be used either for gripping by compression on a turned spigot or expanding into a turned recess such as this. final light sanding. An attractive and durable finish can be obtained quite easily with finishing oil. About 3 coats allowing about 6 hours between each one is recommended. Hollowing out is very enjoyable, provided a few basics are remembered. I teach newcomers to bolt turning to create a series of steps so that the tool's bevel has positive contact with the work before the cutting edge is feathered in. Keep the shavings coming from the tool's leading edge. Work back progressively, deepening, widening the hollows. When I've arrived at the shape and surface finish that I want from the tools, I sand with progressively finer papers. Before rotary sanding tools were introduced, it was very useful to have a reversing facility on the lathe for finer finishing. Reversing is largely redundant. In those days we would use a fibre washer behind the chuck or faceplate to give a more progressive grip for running in reverse. It was an important safety consideration to have the front of the work completely clear of obstructions. So if the work did unwind, nothing could become trapped. I have never had a piece come off or even work loose. In any case, you are working at low speeds with minimal pressure. Another time when a reversing facility can be useful is when polishing or buffing. The polish is driven into the grain fibres from both directions, and this is an advantage with some types of finish. I am using the 2 3/4 inch faceplate come screw chuck to mount the U-blank. The centre screw is fitted and is the primary holding element. Six additional screw holes are machined at an angle around the periphery of the plate to give the added security when needed. I'm going to use 3 of them. A 3mm pilot hole and wax on the threads will make the screws easier to remove in due course. Turning hollow vessels requires different tools and techniques to those required for conventional bolt turning. Most often the work will be mounted with the grain running parallel to the bed, just as if this were a fat spindle. For the initial roughing down of the outside, I keep the tailstock in place. This gives added support so that I can work more quickly. Notice that I am using the conventional bowl gouge for turning the outside, as this has the strength to resist flexing under the heavy leverage that is generated when the tool is a long way over the rest. I work from the larger to the smaller diameters to cut with the grain and obtain the cleanest finish. The bevel of the tool is rubbing the work behind the cutting edge. This controls the depth of cut and gives the kindest, sweetest of cuts. Now, having turned the outside of the vase, I'm going to drill a hole with this 1-inch Forstner bit. This will make life easier for when hollowing. So I've made sure it's on a low speed, and away we go. I'll go down so far, keep winding it and make sure it is clear of shavings. For hollowing out, I'm going to use this Kelton hollower. The sharpening is made quite easy with this diamond slipstone. It's gently rubbed up from the bottom to the top, keeping it flat, rubbing on the bevel, and this will produce a microscopic burr.
Having finished the turning, you must decide what sort of finish you want to put on it. You'll quickly discover which categories of finish you prefer and which are actually suited to the various types of object that you'll have turned. Spindles, for example, may require different techniques finishing than would be required for bowls or egg cups. We supply a range of finishing materials, chestnut products. These are described in quite a lot of detail in the price list, so you can have a good idea of what you may require. A good basic selection, first of all, cellulose sanding sealer. That's a good base coat for most finishes, most polishes. And this is applied with a rag to the rotating work or with a brush. It dries almost instantaneously. And then the actual polish that's applied on top of it can be a soft wax, such as this, which it comes in various shades according to the type of wood that you're using and what you'd like to achieve. That's simply applied, allowed to dry and buffed to a nice satin sheen. Also, this, which you'll see demonstrated on the video, the acrylic gloss lacquer, is very, very useful. It provides a very durable finish, which is resistant to handling and finger marks. Also, you can use Danish oil. That's traditionally a very durable finish, again, used for bowls. That can be supplemented with a soft wax over the top, so the oil can be used as a final coat, or it can be used as a base coat for a wax polish. Friction polish, as its name implies, is applied by friction with the lathe running. It has some advantages for small pieces. It gives a very bright shine, but it's difficult to use on larger pieces. It tends to build into ridges. Spirit stains have a use, even though many people like to retain the natural nature of the wood, on some objects such as standard lamps and some objects made from mahoganies, which tend to look quite dry and dusty in their natural state, even when polished. A spirit stain, or in fact any stain, will enhance and enrich the appearance of the timber. That is sealed and then polished on top of the staining process. End seal is quite useful if you're using limbs, small diameter prunings and so on from trees. If left in the round and unsealed, the ends will tend to split, as you can see on this piece. It's best in any case to leave limbs in longer lengths until you actually need them, because there's almost always some checking on the ends. But this will help to prevent that and preserve the wood as far as it's possible. This has been dipped in this product, and that prevents the moisture from evaporating too quickly from the end grain and causing splitting. Well, we'll demonstrate how some of these are used in the video itself. It takes some practice to be able to use a dry grinder freehand to produce a good cutting edge on the turning tools. But a good edge is essential if you're to enjoy turning. The microscopic irregularities induced by direct grinding on a dry wheel are ideal for keeping the tool cutting efficiently and not overheating. Now, in the absence of some years of practice, a grinding jig is the best way in which to proceed. The TK VB grinding jig enables you to sharpen all your turning tools to a perfect edge with an absolute minimum of fuss or previous experience. It consists of a horizontally and vertically adjustable component, this flat grinding plate, which is used for all chisels and 90-degree gouges, such as roughing gouges. The angles are set by means of templates. You can make your own templates according to what angles you prefer, but that controls the vertical height of the plate, so you adjust the plates up or down, and the horizontal distance from the stone is controlled by this dimension. So in this case, that would slide in, and the plate would be dropped. So, and that's perfectly set for repeat grinding angles. For example, with the plate set, it's a very simple matter to produce a perfect bevel and a perfect cutting edge. For grinding gouges, fingernail profiles, swept back grinds of various bevel angles, the post is inverted and the ball now set to the correct projection, horizontal projection from the tube clamp, and the correct height. That's done by means of the appropriate setting jig. A setting scale on the swing jig enables the angle of the jig to be set according to the tool that's being ground and the type of bevel, angle and profile that you require. When that's set, simply placed on the ball, and the arc of the tool as it's moved around the grinder is then controlled. And provided the same settings are used and that information is recorded on the setting template, then of course the tool will be reground identically every time. So it's just a matter of a few seconds to freshen up the edge.
Thanks for taking the time to watch this video. I hope it's answered all your possible questions on the Hegner HDB 200XL lathe. It certainly, I hope, has shown you all the varied possibilities that this lathe is capable of. However, if you should have any further questions, do not hesitate to contact me or to speak to my sales office.